One of the core reasons React performs so well is because of the virtual DOM. In traditional web development, every change to the interface can trigger a full re-render of the web page, which is both heavy and slow. React, however, maintains a lightweight copy of the real DOM in memory. This is the virtual DOM. In traditional JavaScript, if an element is changed in physical DOM, browsers calculate the impact on adjacent elements like style and layout adjustments. Since these calculations are complex, browsers can end up re-rendering entire sections of page based on perceived impact. In React world, however, whenever you update a component, React first updates the virtual DOM. It then compares this new version to the previous one, a process called diffing. By calculating the minimal set of changes needed, React updates only the part of the real DOM that have actually changed. This targeted update process results in faster rendering and a smoother user experience, especially for complex applications. Consider a table displaying data, HTML on left, DOM on the right. In traditional DOM manipulation, updating a single cell, say changing data 4 to data 10, can trigger a reflow and repaint of the entire table because the width of the text changed. This means the browser recalculates the layout and potentially re-renders the body or, in some cases, the entire table, which can be inefficient. With React's virtual DOM, the process is more efficient. When data 4 is updated to data 10, React updates its virtual DOM first. It then identifies that only one TD element has changed. Consequently, React updates only that specific cell in the real DOM, minimizing reflows and repaints. This selective update enhances performance, especially in applications with frequent UI changes. Understanding virtual DOM not only shows you why React is so efficient, but also why it scales so well as your app grows. Now that we have unlocked this secret, let's jump into building our first React component using JSX.